What is the formula for derivative of inverse functions? The formula is f inverse prime of x is equal to 1 over f prime of f inverse of x. Now, how can this help us solve our problem here? What's the problem asking us to find? It's asking us to find g prime of 3. Okay. So find g prime of 3. How do we do that? Which of these two equations can help us? Well, this is the only equation that has g, so let's take a closer look at this one. G of x equals f inverse of x. How would I come up with g prime from this equation? G prime of x would be equal to f inverse prime of x. So g prime of 3 of 3 would be equal to f inverse prime of how much? Well, we're plugging in 3 for x. So 3. Now, how can this formula help us? We're just plugging in 3 into this formula here. Okay. So what do we need to find here? We need to find f prime. Okay, so f prime. What else? We also need to find f inverse of 3. What's f prime of x? So we've got f of x is equal to x cubed plus 4x minus 2. How do we find the derivative here? Well, what's the derivative of x cubed? What do I need to do with the 3? I need to move it in front of the x. And x gets raised to what power? I need to subtract 1. Okay. What's the derivative of 4x? Four. Okay. So that's f prime of x. How do we find f inverse of 3? Well, how do we find f inverse? To find f inverse, okay, so I'm going to get another sheet of paper. Okay, so f of x, which is the same thing as y, is equal to x cubed plus 4x minus 2. What do I need to do with x and y to find the inverse? I need to swap them. Okay, and I wanted to find f inverse of 3. By the way, whatever I write down on this sheet of paper, you don't have to write down when showing your work. I'm just writing it down to elaborate on certain things. Okay, so this is for the inverse. So if I want to find f inverse of 3, what do I need to do with this equation? Plug in 3. Okay, and how do I solve this equation? Well, first, let's move everything to one side of the equation. So I'm going to subtract 3 from both sides of this equation. So y cubed plus 4y minus 5 is equal to 0. Okay, so we have to solve this. How are we going to do that? Well, you might observe that the coefficients are integers. This is 1 times y cubed, so this is also an integer. So you might guess that the solution here is also rational. You can try the rational root theorem. Okay. So the rational root theorem states that all possible roots of this are going to be of the form m over n, where m is a divisor of this number, and n is a divisor of this number. Since n is 1, our root has to be what? It has to be an integer. But okay, let's plug in some values for m and n. Okay, so for example, we could try plugging in -1, because that is a divisor of -5. We can try plugging -1 for m, and we could try plugging in, let's say, 1 for n, because 1 is a divisor of 1. Yeah, these divisors can be positive or negative. Okay, so -1 divided by 1 is equal to -1. Let's try plugging this in. So -1 cubed plus 4 times -1 minus 5 equals 0. Wait, is this true or not? No. So let's try another another possible root that is close to 0. Right, I strategically picked -1 and 1 because I wanted a root that was close to 0 so that calculating this would be easy. I wouldn't have to use a calculator to figure this out, right? Because this is -1 minus 4 minus 5. Yeah, this is not 0. Okay, but with rational root theorem, you kind of have to guess and check. Let's try 1 over 1. So 1 cubed, right? We're just plugging in 1 into this. Oh, sorry. We're plugging in 1 into this now. Right. Okay, so 1 cubed plus 4 times 1 minus 5. Is that equal to 0? Yes. Okay, so that means f inverse of 3 is going to be equal to 1. All right. So I'll just say f inverse of 3. So basically, to summarize what we have here, I'm going to say f inverse of 3 is the root of this. F inverse of 3 is the root of this equation. So basically when we swapped x and y and plugged in 3. Okay, and this, yeah, we got y cubed plus 4y minus 5 equals 0. And then we solved it with the rational root theorem, and what did we get? F inverse of 3 is equal to 1. All right, so can we finish this problem off now? Can we plug what we have here into this? Yes, we can. So let's go ahead and change this to 1. Okay. So 1 over f prime. Okay, let's just write it like this. Yeah, let's just write it like this. 1 over f prime. Okay, so this is kind of our rough draft. I'm gonna write down our official solution that we're gonna turn in on here. So this is our rough draft. I'm just gonna put rough draft at the top. Rough draft. Okay, so 1 over f prime of f inverse of 3. Okay, so what did we just do? What can we change this to? 1. Okay, and how do we figure out f prime of 1? What equation do we use from here? Use this one? Okay, so 1 over 3 times 1 squared plus 4. And that's equal to 1 over 7. Okay, but this is our rough draft. This is not what we're going to be turning in. Okay. So basically, we needed to find f prime of x and f inverse of 3 before plugging it into the formula. So, okay. So we'll just say this, we find these things first and we plug them into the formula and that'll give us our answer. All right. Yeah, basically at this point we're cleaning up what we wrote down here. Okay. So, let's see. Okay, so I'll just copy this part first. Okay. So now we can plug it into this. To clean it up a little bit, I'll just combine this and this. So g prime of 3 is equal to f inverse prime of 3, which is equal to 1 over f prime of f inverse of 3. All right, and then let's go back here. Yeah, so now we're going to copy this part. So start here because we already wrote this down. Okay, perfect. So basically, I think the grader will know. Okay, so they found the derivative. They found f inverse of 3. Then they plugged it into the formula, and they got 1/7.